And welcome to 16.2, where we're talking about concentrations of solutions. In this section we're going to be dealing with what concentration is, how do we express concentration, how do we make solutions of a given concentration, and then dilute them to another concentration. So let's go ahead and jump in and talk about a concept called molarity and a few definitions here. First of all, a dilute solution. A dilute solution is a solution that has a relatively small amount of solute dissolved in it. As opposed to a concentrated solution that has a relatively large amount of solute dissolved. Now, those terms are used, I want to say they're very commonly used, but they don't tell you exactly how much solute is dissolved. When you say something is concentrated, that doesn't necessarily mean that it has more than one or the other. It's simply saying that it has a relatively large amount. All right. So let's talk about how we can quantify the amount of solute dissolved, and we can quantify that using what's called molarity. Molarity is simply the moles of solute per liter of solution, and it's given an abbreviation capital M, and we refer to that as molar. So the units are going to be moles over liters, which is the same as the capital M, which means molar. And so let's go ahead and try a few sample questions and see if we can't get the hang of what molarity is all about. So, example number 1 says, intravenous saline solutions are often administered to patients in the hospital. One saline solution contains 0.90 grams of sodium chloride in exactly 100 mils of solution. Calculate the molarity of this solution. So, you know that molarity equals moles of solute per liter of solution. We're looking to figure out what the molarity is. Do we know the number of moles? Well, not exactly. We have the mass in grams of sodium chloride. And do we know the volume in liters? Well, no, but we do know the volume in milliliters. So if we take the grams, change it into moles, take the milliliters, change it into liters, now you have what you need. So let's go ahead and do that. If you have 0.90 grams of NaCl, to go from grams to moles, use the molar mass. 1 mole of NaCl has a mass of 58.44 grams, and that gives us 0.01552 moles of NaCl. So we can plug that in. Moles of NaCl. Next, we need to determine the volume in liters. Well, we have 100 milliliters of solution. In 1 liter, there are 1,000 liters. I'm sorry, 1,000 milliliters. So the milliliters divide out top and bottom, and that gives us 0.100 liters of solution. So now we can plug that back into the equation. And so if you take your 0.01552 divided by your 0.1, that's going to give us 0.155, if we round it to 3 sig figs, moles of NaCl per liter of solution. Or another way to state that would be to simply say that it's 0.155 molar NaCl. Either way is acceptable. Typically you're going to see this way written on a bottle, but when you go to do calculations, you really want to use this form over here because it gives you the units of moles and liters that you're going to need to divide out. Alright? Okay, next problem. Example number 2 says, a solution has a volume of 2 liters and contains 36 grams of glucose. If the molar mass of glucose is 180 grams per mole, what is the molarity of this solution? All right. So once again, start with your relationship of molarity equals moles of solute per liter of solution. We need to calculate the number of moles. So we have 36.0 grams of glucose. We're going to multiply that by 1 mole of glucose over the 180 grams. And so that's going to give us a total number of moles of 0.20 moles of glucose. So we can plug that into our equation. So we have 0.20 moles of glucose. I'll just abbreviate GLU. For our volume, we're dissolving it into a total of 2 liters of solution. So we're already in liters, so we're good. We can just plug that in. Go ahead and divide the 0.2 divided by 2, and that's going to give us 0.10 moles of glucose per liter of solution, or another way to express that would be just to simply say 0.10 molar glucose. And voila, there you go. Now in example number 3, we're going to change this up just a little bit because we're not going to solve for molarity. We're going to tell you what molarity is. Let's go ahead and take a look. Household bleach is a dilute aqueous solution of sodium hypochlorite. How many moles of solute are present in 1 liter, 1.5 liters of 0.70 molar sodium hypochlorite? And then what mass is present in that sample? So, again, start with your equation. Molarity equals moles of solute per liter of solution. So therefore we know that 0.70 molar, that's the concentration given in the problem, is going to equal X number of moles per 1.5 liters of solution. Now remember that molarity is moles over liters. So if I isolate my X by multiplying by 1.5 liters on both sides, notice that this entire term divides out top and bottom over here, and my liters divide out top and bottom over here. So now I'm left with X, which is going to equal 1.5 times my 0.7. The only unit that's left is moles, so we're good there. And 1.5 times 0.70 is going to be 1.05 moles of sodium hypochlorite. Alright, so that's the first question. How many moles of solute are present? In the second problem, or the second part, it asks what is the mass of the sample and gives us the molar mass. So if we have, so this is the first part. So if I have 1.05 moles of NaClO, or usually it's written as OCl, and we multiply that by 74.45 grams per mole, which is the molar mass. The moles divide out. I'm left with grams. And now 1.05 times 74.45 equals 78.2 grams of sodium hypochlorite. And we'll write it that way this time. So there you go. So the calculations, you're always going to have one variable that you don't know, and you have the other ones that you do know. Just plug them in and solve. We'll let you try example number 4 on your own here. In the next podcast, we'll go over example number 4, and then we'll continue our discussion going into making dilutions. We'll see you next time.